This video is related to p-n junction. Note: please see this video by pause. Semiconductors and p-n junction diode. Content: first of all, we learn the mechanism of the formation of p-type and n-type semiconductors. After that, mechanism of the formation of p-n junction. And the last one will be different biasing of the diode. Now let's start. The formation of n-type semiconductor. To make an n-type semiconductor, we take semiconductor like silicon or germanium, and plus 5 valency doping elements such as arsenic, as we can see in this picture. An n-type semiconductor, an extra electron remains unbonded, which is free to move in the lattice. This unbonded electron has very low ionization energy, or even at room temperature it will be free to move in lattice. Why? This free electron has very low ionization energy? Because arsenic atom has 8 electron on its shell, so octave arsenic atom has completed, so it becomes stable atom. So, now, free electron creates instability in the lattice, so the leaving tendency of this free electron become very high. So ionization energy become low. In n-type semiconductor, holes are also present, but the condition is number of holes present in the lattice is less than number of free electron. Note: crystal maintains an overall charge. Neutrality. How? Due to free electron, parent atom become positively charged. So neutrality maintains in the lattice. This positive charge is called as a mobile charge because it cannot move in the lattice. Formation of p-type semiconductor. To make a p-type semiconductor, we take silicon or germanium crystal type of semiconductor, and the doping element is +3 valency element, such as boron, B. In p-type semiconductor, a vacant place is developed which has capability to accept an electron. This vacant place has high capability to accept an electron. Why? Because boron atom wants to complete its octave, that means it wants 8 electron, but here only 7 electrons are there, so this vacant has high capability to accept an electron. A hole can migrate at room temperature. In p-type semiconductor, free electron is also present, but the condition is number of holes is much more than free electron. Note: crystal maintains an overall charge neutrality. Why? As we have already discussed about it, it is due to parent atom. Parent atom has negatively charged and holes are positively charged, so charge neutrality maintains in the lattice. This negative charge is called as a mobile charge because it cannot move in the lattice. This is a mobile ion called acceptor core. This is hole can be moved as mobility. A p-n junction is the basic building block of many semiconductor devices like diodes, transistor, etc. P-n junction formation. In the formation of p-n junction, there are 2 types of processes occur. 1. Diffusion. Diffusion mean one molecule or atom move from high concentration region to low concentration region, then it called as diffusion. We discuss about it later in detail. 2. Drift. E starts moving N to P simultaneously, holes start moving P to N. This is called diffusion of electrons and holes. Why? Because concentration gradient is developed in p-n junction. What is concentration gradient? Concentration gradient defined. The formal definition of a concentration gradient is the process of particles, which are sometimes called solutes, moving through a solution or gas from an area with a higher number of particles to an area with a lower number of particles. The areas are typically separated by a membrane.